Okay, folks, today is without a doubt the best lesson of the year. You might not realize it while it's happening, but you will look back at this lesson as the complete turning point in all of this. You've paid a heavy price through 10 academic, a little bit. 11 U math, that was a heavy price to pay for knowledge, yes? Advanced functions, the payoff was almost there at times. And then through the first two chapters of this and learning about limits. But it's all in a collision course. All the stuff from advanced functions, all the stuff from limits is all in a collision course, and the apex is today. Now the title is mysterious. Using the difference quotient to find the slope of a tangent. Titles like this are hilarious to math teachers because the title should be the last slide, not the first slide. You see a title like this, like, what? What's going on? Not all math titles like that, but today it is, okay? And to really get context for what's about to happen here, we're going to rewind to this lesson in advanced functions, which was a long lesson. It took me 2 full days to convince you that we could find the instantaneous rate of change at a particular moment using only one x value, using only one time. Well, that's a bit of an exaggeration. We had to come up with the other x values. So I asked, what's the instantaneous rate of change at 1? And then we went, well, let me check 1 to 2, 1 to 1.5, 1 to 1.001. And we got closer and closer. We came up with the second value, and eventually this column approached a certain value. It was limits that we were talking about. We just didn't use the word. As t approached 1, the slope approached 15.2. The limit as t approaches 1 equals 15.2. That's what was going on there. But I didn't have the limit words available yet. Then we got distracted by factoring, rational functions, trigonometry, logs, because we had to go get those things all fixed up before we could come back. But really, I'm now teaching the next lesson after this, is what I'm really doing. That's what I'm really up to now. Just for a little more review, we had several methods to do this. We had the chart, which was easy to understand, but long and boring. Yes? Then we had the slope of the secant method, which was hard to build, but much more efficient. So it was sort of medium like that. Today I will teach what we called method 3, which I referenced in advanced functions. I told you about it, but most people just ignored it. You had enough going on. And so now I'll go back and use limits to talk about method 3, which is even harder to understand, but maybe the most powerful thing in mathematics there is. Okay, all that to get back to this slide. And this, as a warm-up, says, consider the function, and I chose one that was medium complicated, root x plus 7x minus 1. Determine the slope of the secant and determine the slope of the tangent. So I'm actually going to go back and do the advanced functions work on this particular function. But I'm going to try and teach it in such a way that I'm re-explaining everything that was going on back then. Hopefully clicking into a whole bunch of warm memories of advanced functions. But then taking that stuff and building something better. Yes, by the time I'm done. We won't do much of what I'm seeing on this page. This is just, okay, where were we again? What was going on here? Because when was it? End of February last year when we were pounding away on this, okay? This says find the slope of the secant. So just to get a not accurate picture of what's going on, I don't know why. I always draw the curve like that just to visualize what's happening. What they're asking me to do is from the point x equals 1 to the point x equals 9, find the slope of the secant. And the secant slope was just connect up those 2 points. Secant slopes don't really care about the curve all that much. They only care about the 2 points. So then write that on there. All your review of advanced functions that you're going to need is right in this diagram. slope of the secant. So I'm going to write a whole bunch of stuff that's unnecessary to solve this problem, but is necessary to review advanced functions. M secant equals average rate of change. Oh, your physics and your chemistry teachers are happy that I'm writing this all out for you. Equals AROC is the short form. We don't write average rate of change a whole lot. We get bored with writing all that out, so we write average rate of change. But it gets better. Equals rise over run. And I wish my grade 10s could be watching this videos on my grade 11 to go, oh, the calc people are using all this. Rise over run equals y2 minus y1 over x2 minus x1. That's what that was all about back in grade 9. We were getting ready for this moment. Equals f at x2 minus f at x1 over x2 minus x1. And if you're completely bored with writing all this, I know this is just me reviewing maybe all of high school in one example. But in the end, finding slope of the secant was just finding y2 minus y1 over x2 minus x1. This is just function notation. It means sub in these two different things. So I've got my two values here. I want f at 9 minus f at 1 over 9 minus 1. Now I'm starting to get down to business here. If you were being lazy and not copying things, maybe now's the time to join in. Go, yes, yes. As you say this, I'm remembering all this. This is what we want for slope of secant. Oh, okay, well, I got to find out what f at 9 and f at 1 is. I'll just go over here. Sometimes I like doing that in questions that have fractions and stuff in them. If I got to do a calculation there, I got to put the calculation in here. Just go over here and go, just a second here. F at 9 equals root 9 plus 7 times 9 minus 1 equals 3 plus 63 minus 1 equals 65. That was this point. And incidentally, if the grade 10s were watching this lesson, they would be saying, are you just finding the slope between those 2 points? Like, well, why are you going on and on about this? And for them, that's what exactly I'm doing. Slope of secant is just slope between these 2 points. And down here, f at 1 equals root 1 plus 7 times 1 minus 1 equals 7. After all that, y2 minus y1 over x2 minus x1 equals 58 over 8. Maybe I could reduce that to 29 over 4. Maybe in certain questions, let's get some wisdom in this. Maybe if this was a real life word problem, maybe we would want the decimal, 7.25. I don't know. It depends on the context of what's going on. Often the fraction is nice to use, but I'll put the decimal there just to be aware that maybe that's what we want there as well. Okay, tell me. We're going to build on this, so if there's any questions about that, now's a great time to let me know. Agam.
Why did you square root 9
The function said, if I want to plug something in, square root of the x value plus 7 times the x value minus 1.
Do you have the x value over here?
Yes, they gave me the 2 x values. Key point. Well, 2 key points, actually. Key point. In average rate of change, they give me both points. In math, average rate of change is supposed to be easy. The grade 10s would definitely follow this. They'd be like, yeah, just slope. Why are you getting so excited about this? Boring, they say. But because we're given 2 points, average rate of change gives you 2 points. What happens next seems impossible to them when we do it with 1 point. Yeah, well, you probably know what's coming. Other questions? All right. More review of advanced functions before we build something better. Determine the slope of the tangent at the point where x equals 4. I will do the secant slope method, but within there I'll talk about the table at some point. When they're only given 1 point, I draw a very similar picture. 4 comma, don't don't know. And over here, I don't announce the x value yet. That was the difference with the secant slope method instead of the table. I go, yeah, I'm going to do some x values. And I'm going to do them close to 4, but I'll do that later. Now, how do I get, and if you didn't really understand this before, but you could just do it, let's just talk about why this works. I've got an x value of 4. How do I get the y value to go with that? No trick. This should be pretty straightforward. Let's sub it in, yeah, to the function. That's what I'm going to do. So I'll actually write that in here. Let me erase that thing. And I already forget the function. What was it? Root x plus 7 times x. So root 4 plus 7 times 4 minus 1. I don't think it's particularly good form to write that in the brackets, but I am for this example so that you understand clearly what's about to happen next. So that's 29, is it? Root 4 is 2, plus 20 is 30, 4 comma 29. That's my initial point. And sometimes they actually give you the point, and sometimes you got to sub it in. But I like this example because it didn't sub it in. Then I'm going to build a formula, and I'm not going to announce the x value till later. I'll put the x value in later. Keep remembering that. That's key to what we're going to build in calculus here, is that all I'm doing here is saying, I'm going to use another x value, but I'm not going to state what it is yet. Maybe you work for me, and you come and say, what x value do you want me to use for this? And I'll go, yeah, I'll tell you this afternoon. Just build the formula for now, and then we'll plug it in later. You're like, okay. So some x value goes here, but if that's the x value, I just sub that x value into the formula to get the y value. In this particular case, subbing in x gives me root x plus 7x minus 1. That's an interesting way to phrase that, to explain why you just put the function there. It's just the subbed in version. It's the y value that you would get. That is, if later on I announce the x value I'm going to use, say 4.1, you put 4.1 here, and you'd go root 4.1 plus 7 times 4.1 minus 1. And this allows me to build a formula. So I don't have to sub in the x till later. And here's the formula. It's this simple. It's a secant slope formula. Slope of the secant equals y2 minus y1 over x2 minus x1. You're like, it said slope of tangent, Mr. Todd. You raise your hand. Mr. Todd, slope of tangent. I'm like, I know. Hold on. Slope of secant first. Huge. Huge. If you're dead asleep right this morning, that's the biggest thing I'm going to say. Slope of secant first. Then we'll use that to get slope of tangent. So here's the slope of the secant. Is this starting to ring a bell? Over x minus 4. And I can tidy that up a little bit, maybe a lot. There are times when you can tidy it up a lot. This one doesn't tidy up a whole lot. Root x plus 7x minus 30 over x minus 4. Let's make sure I haven't made any mistakes there. Root x plus 7x minus 1 minus the 29 and x minus 4. Now, what does this secant slope formula do? What does it do? If I give you a number now, say 4.1, you don't have to sub it in here to get the y value, then build the slope, then figure it out. You can just take your 4.1 and sub it get here and jump all the way to secant slope. This is the table method. I'm going to go choose some x values, skip all the other nonsense that went on in the table. Yeah, I'm just going to jump over all of that and jump all the way to the secant slope, the slope of the secant. Now, right now, limits, if I was a math coach, right now limits are on the bench jumping up and down going, I'm ready. Let's do some limits. Here's how we're going to do them using the advanced function methods, but we're almost done with that. We're almost ready to just call it a limit. So then finally I show up in the afternoon after my long lunch, and I go, and you go, what? Now you got to tell me now. I'm ready. What x values would you like to use? I said, well, go ahead, use 4.1. And you sub 4.1 of the secant slope. You don't sub it into the y value. You don't sub it into the delta y or the delta x. You don't do any of those things. Well, you do, but you got a formula that does all that. I skip all of this and get the answer. Well, let me get my calculator. You try punching it in too, so you remember how to punch these things in. Do boo ba-da-ba-dee-dee. And your calculator does a better job of this than me. I can't remember. Does mine show fractions or doesn't it? I forget. If I hit the fraction button, oh, I do get a fraction. I thought it didn't do that, so this is just like yours. How nice to have a calculator that does fractions. Okay, so here we go. Root 4.1 plus 7 bracket 4.1 minus 30 over 4.1 minus 4. Now, after all that typing, you're like, I don't know that this is actually saving time, Mr. Todd. I got to tell you, I could have just subbed, done the slope. Is this that much better? For the first one, maybe not. It's not a big time saver, but it is going to be in a second. Do you get 7.24? I'll put them all the decimals down just to make the point. We don't need all the decimals, but 248, 4, 5, 6, 7, 3, 1. That's the average rate of change. That's the slope of the secant. That's this slope here. It is close to the slope of the tangent, but I don't know how close it is. See, here's slope of tangent. And I have no idea if this picture is accurate or not. I don't know how far away I am. There's only one way to know. Get a lot closer and see what happens. So that's why then I go to 4.01. And in advanced functions, I said do at least 3. But technically speaking, 2's enough if this works out really well. If I get something really close here, I might be done. I've got to approach 4. I've got to keep getting closer and closer to 4. I've got to go limit as x approaches 4. I've got to be sure about where this is heading. And now you see the advantage of the formula. I just go up there and change all those 4.1s to 4.01s. Do, 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 boop. Down, over, 01, 7.2498, 43945. Is it enough? Are you satisfied that the answer is 7.25? Does the limit as x approaches 4 equal 7.25? Maybe you're not satisfied. Maybe you're like, it's pretty good. We'll go one more time just to be sure, but now life is easy. I just go back and add another 0 in there. You computer programmers should be frothing at the mouth going, I can make this do any limit, anywhere, anytime, with about 6 lines of code. Ding, answer. And you're right. You definitely can do that. Are you satisfied now? 7.24998. $4,377. And here's what we would have said in advanced functions. I'll write advanced functions in red. Advanced functions would have said, therefore, slope of tangent equals approximately 7.25. We would have been pretty happy that it was approaching some value. Here's us saying the same thing in calculus. Therefore, the limit as x approaches 4 of the slope of the secant equals the slope of the tangent equals 7.25. See, back then you would have said, Mr. Todd, please tell me you've got something better than this. And I'd be like, yeah, I do. Wait till October, and I'll beat this up, and I'm just getting started. I'm just getting warmed up as far as how much better this is going to get. But I pause for questions. What questions do you have about that process? Anything, because this is key to it's key to understand what's going on here, so that what happens next, you see the beauty of it. Any?
Why is it secant on the outside of the values are 7.25, but then the tangent?
Right. The secant slopes are 7.248. That's a close answer. A closer answer to the slope of the tangent is 7.2498. A closer answer to the slope of the tangent is 7.2499. We're getting closer and closer and closer. So what I'm doing is I'm making secants like this that are getting closer and closer to the answer. Once I've established what the limit is, once I've looked at it and go, I know what's going on here, which if you're really paying attention, like, are you sure? Are you sure it can't go 2499 and then go 7.3, 7.9? Like, are you sure that it's settling in? Like, we're sort of believing in this. Once I see where it's headed towards, then I know that's what the slope of the tangent must be, because this is getting closer and closer to the slope of the tangent. What did we do last year to make sure that it didn't take off is we went from both sides. Do you remember on the test then having to do it from both sides? To crush it in between. That's why limits go from left and right. That was setting that all up. So the limits will take care of this because the limit comes from both sides. So I'm not perfect yet. I'm sort of just, that blue line is not perfect. It's just sort of like, oh, that's what we're working on here. Did that answer your question? Okay, other questions? All right. But just in case that's not clear, the PowerPoint goes through the theory with some beautiful animations. The slope of a tangent. This is a better answer to what Annie was asking there. Recall our method for finding the slope of a tangent to a curve at the point P. Here's what our method was in advanced functions. Determine the slope of the secant line from P to another point Q on the curve. We started close. Actually, we didn't. The first example I ever did, I had to start close. And then by the end of the example, you're like, why didn't you just start closer? And then we did. Later on, we started close. And then we moved Q closer and closer to P, each time calculating the slope of the secant, knowing we must be getting closer and closer to the slope of the tangent. Repeat this process using points on the other side. I didn't always force you to do the other side, but sometimes I did. And use the limit. Okay, this is not the word we used in advanced functions, but it's what we were doing. Use the limit. We said, okay, if it goes 7.249, then it goes 7.2499, then it goes 7.24999, I can go, I see where this is headed. And that's what a limit is. Where is this headed? It's heading for 7.25. Here's the beautiful animation that shows what's going on. You start with a point P that you want to find the slope of the tangent at. And you use these Q points on either side to get closer and closer. And as you get closer and closer, the slopes of those secants approach the slope of the tangent from each side. Whew, okay. The difference quotient. Okay, finally the title of the lesson. Finally, now, we can step out of February and step into October. Now consider a slightly different view on the same idea. I'm actually going to say the same things I just said using different words and terminology to get ready for something better. Words and terminology that we've been using this chapter. Suppose we want to find the slope of a tangent at a point P which has coordinates a comma f at a. Don't let the f at a confuse you. All that's saying is once you have a, once Mr. Todd gives me the a, which is like 2 or like 7, if you want the y value, just sub it in to get the y value. That's all f at a is saying, is sub the number in. A good question would be, are you always going to give us the a value? And the answer is no, we'll get much better than that. But for now, let's pretend I'm going to. Let's pretend I'm always going to give you this value. And like all math questions, eventually we'll go, can we do it in reverse? And we'll see if we can do it in reverse. But for now, let's assume I'm going to give you the a value. So I give you an a value. Now I introduce the letter h. And h will be the gap. We're going to change our perspective. Instead of saying 2 to 2.1 or 2 to 2.01, we'll indicate an h value. And h will be the gap between the value I give you and your new value. So if you want to go 2 to 2.1, you use an h of 0.01. If you want to go 2 to 2.001, you use an h of 0.001. So h is changing the perspective to go, what gap do you want? So instead of asking me, what x value should I use, Mr. Todd, you ask me, what gap should I use between this value and the next value? So what I get is a new point that's at a plus a little bit. So if my a value was 2, this is like 2.1, 2.01. That h is just how far over I go. And don't let the f at a plus h confuse you at all. All that is once you have your x value, sub it in to get the y value. So that f over there makes this thing look confusing when all that's saying is sub it in to get the y value. What I get then is, for a slope of a secant, this. Now just stare at that for a second. Don't give it too much credit. And then I'll explain why this is such a big deal. To find the slope of the secant, this is exactly the same as what we were doing, with different letters, that's all. You're saying f at a plus h is the second y value. F at a is the first y value. And then the denominator is a plus h as the second x value. Subtract a as the first x value. Please do not be intimidated by this. Within 24 hours, you'll think this is pretty straightforward stuff. This will not cause you a big problem. And it's the same thing we were doing, just writing it differently. Now, one good thing that happens is the denominator simplifies up nicely. See, a plus h minus a, you subtract those, and what you end up with is just h on the bottom. This is finally your new best friend. Yeah? Sometime in grade 9, I think, I wrote the slope formula on the board and put a heart around it. Did I do that in most of your classes? And said, hey, if you got this thing, you don't need a date to prom or to color night or anything else. This is your best friend. This will pay off better than any date will. Yes? In the long term. This is the one for calculus. It's too good. It is too powerful. It's awesome power in a formula. And it's the same thing we've been doing. It's another way of writing it. But algebraically, this thing has powers you will not believe as it happens. This thing is called the difference quotient. That's what we're talking about. We're going to use the difference quotient. Someone raises their hand and goes, isn't the difference quotient just slope of secant? Like, isn't it the same thing we've been doing? But now you're trying to confuse us with new symbols? That's what it might feel like. No, I'm trying to give you more power. This has algebraic powers the old method did not have. Yeah. You got to see it in action first. Most importantly, the slope of the tangent line at P is the limit of the difference quotient as h approaches 0. We need the animation first. Does the animation go? No. There it goes. As that point gets closer, as that h gap gets smaller, what gap do I want to use? 0.01, 0.001, 0.00001. As much gap, a small gap as we can use. And now there's the limit. And it opens up all your algebraic powers from all the homework you did on limits. Does this expression for the tangent slope take into account secant slopes from both sides? Do limits, when we write limit as h approaches 0, do we mean from both sides? We already mean that. We built that in on purpose for this moment. So we won't have to worry about the left and the right thing anymore. That'll be built into here. If this was a really cool school, I would now give you $10 for lunch. Actually, $10 won't even do it anymore, will it? Get a combo with a large fry and a large drink. $13, right? So if I now gave you $15 for lunch and just told you, go have lunch, sit around, and just stare at that for an hour, come back this afternoon, and we'll keep going. That would be cool if we were at a school like that. That's how important that thing is. But of course, we're on the clock here, so we'll need to continue. Yeah. How about some examples? Good. Some examples. I think the rest is examples. It's all on a separate sheet, I think. 1, 2, 3, 4 examples, my brain tells me. Do your notes say the same? This says, oh, we jump right into the deep end. We don't even wait around. We jump into some crazy example right off the hop. Okay? Determine the equation of the tangent to the curve. The equation of the tangent. What equation of tangent? Okay, hold on. This should be part A and part B. If I was not trying to jump into the deep end. Part A. Slope of tangent. And then part B would be that question there. Okay, so just a little y equals mx plus b coming at you in just a second. A, find the slope of the tangent. I'm going to draw the picture every time today. But I think you'll find you will stop drawing the picture. Okay? Here's the picture of what we're going to do. We're going to have a point, A comma f at A, and I'll tell a gigantic lie. I'll give you the A every time. Every time in the question, I'll give you the A. Okay? And I'll tell you when I'm going to break that lie. Then there'll be a second point. Moved over just a little bit. How much little bit? Just h. Just move over h. H is a really small number. And then what will the y value be? Is someone on this? How do I find the y value once I have an x value of a plus h? Just sub it in. This writing f at a plus h messes people up because they're like, something complicated. No. They're just saying, whatever your x value is, you just sub it in, and then that'll give you your y value, okay? You won't write any of that as you get better at these. Here's what you'll write. You'll write down your new best friend. M tangent equals limit as h approaches 0 of f at A plus h minus f at A all over h. Oh, now you're ready for your advanced functions friends who are crying about their homework. They're doing Unit 2 right now. You can be condescending. They'll come up and say, 2 to 2.1, 2 to 2.1. Like, oh, you do it that way, you guys? Oh. Let's see if I remember. It's weird that way. Because you're dating this thing now. You're like, You poor children. Yeah? You're exactly 12 months older than them. No, you're the same age as them. Yeah, you're the exact same age. Like, oh, you poor kids. Aren't you cute with your 2.1? But 2.01's in there. It's right there. It's still there. We just have a more powerful weapon to handle it. So better yet, and I'll write over here and try to make this a little smaller, a little more efficient. Better yet, you're going to go m tangent equals limit h approaches 0 f at 4 plus h minus f at 4 over h. Now just put the brakes on for a second before you get too condescending with the advanced functions people. You got to know what to put in here. This is the a value. So if you're going to have trouble with this, it's going to be right there. Here, a equals 4. In this particular example, they gave me the point that I wanted to use, which was the 4. You say, what about the negative 9? Let's pretend I don't see the negative 9, and let's watch where the negative 9 comes up. It appears here. Before you get too excited, there is some algebra coming here. And it's why we beat you up with algebra in the first 2 chapters of 11U, in chapters 3, 4, and 5 of 12U, so that this particular moment wouldn't intimidate you. I'm going to sub 4 plus h into the function. What? Yeah, watch this. Negative 4 plus h squared plus 3 times 4 plus h minus 5 minus f at 4. So that's negative 4 squared plus 3 times 4 minus 5 all over h. You could or should be sad about what just happened. You're like, you said this was going to be awesome. This does not look awesome to me. Stick with me. Give me 10 days. before you decide this isn't awesome, because it is. You've got some algebra to do. Let's just talk about this bracket for a second, though, okay? Negative 4 squared is negative 16. Plus 12 is negative 4. Minus 5, negative 9. There's the negative 9. So if you have that y value, that's all that this is the negative 9. So I'm going to write that over top. To go, that's just subbing. It's just doing the subbing for you there. So you might not need all that step. Then I'll do the rest of the algebra reasonably quickly. But I will pause for questions at the end. But I want you to notice that this algebra will be very repetitive. Most questions will have some description of algebra like this. All right, here we go. And I'll pause there to wait for your algebraic questions, because I need to tell you, the next 2 months of our life, mostly, is you going, Miss Todd didn't work out, and me going, oh no, that's a 6, not a 7. Oh no, that's a negative. Oh, 3h and 4h is 7h. You know, like little mistakes like that. The big ideas here, I've already explained the big ideas of the next month right here, probably. It's going to be the algebra that's going to really cause a problem for us through here. So we're going to fight with some algebra. So let's start with fighting with this algebra by you looking at those few steps and deciding what you want to talk about. Then we're going to pause for a really giant, scary question. Tell me, tell me, tell me. Which step of the algebra do you want to talk about? Don't be shy. This is our game the next month. Where did you get that negative? Why is that a 16? Why is that an 8? Hi, Mrs. Todd. And you're on a video, aren't you? Now you're on video asking me for a toonie. This is making my life.
I looked and to see if you had a microphone.
I've got my fancy microphone on. Why are you sorry? Will that do? You can get change?
Sorry.
No, don't be sorry. They're looking at the algebra right now. Tell me, what algebra steps? It's all beautiful. If it is, we're in better shape than you could possibly imagine. The next month's going to be good if you just followed what the steps I did there. Because there's a lot of this going on the next little while. The ideas aren't going to change for a while. But then someone raises their hand and goes, hang on a second here. I can see through this problem. I can see what has to happen. You're going to try and sub in h equals 0 here, and it's never, ever, ever going to work because there's an h in the bottom. How can you possibly sub in 0 into the denominator and end up with some kind of answer here? Ms. Todd, you've built something that can't possibly work. When there's a 0 in the denominator, we cannot find the limit, comma, unless, what's the unless? What situation actually does allow us? See, if it's just 0 in the denominator, this is going to be undefined. What situation do we need to develop so that I have a chance? 0 over 0. Somewhere along the way, if this is going to work, If Newton was right, Newton wasn't the only one. Newton and Leibniz were all building this about the same time. If Newton was right, something has to happen here. So you look at your algebra and you're like, no, the top's like 16. Oh yeah, like 16. Minus 16. For these to work, somewhere along the way that'll happen. All of the constants will cancel out. That's why Newton and Leibniz were so excited in the 1700s. They went, watch, look. Negative h squared, negative 8h plus 3h is negative 5h, negative 16. Oh, come on. You got to get out your cancel pen out of excitement and go, ha, 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 ha. It's calculus, baby. 4 methods now. If I sub in 0, I get 0 over 0. I'm happy now. I'm okay with 0 in the denominator. That is fine, as long as I get a 0 in the numerator too. This could be a whole. This might be a whole. You can't have h equals 0. Well, no kidding, you can't have h equals 0. You can't have the gap be 0. That's not a thing. But you can find out where it's headed towards as h goes to 0. Where is it headed towards? Not what is it. It isn't anything. It can't be something. But where is it headed towards? There's a hole in the algebra. What are my 4 methods? Square root, use the conjugate. No, that's not one of those. Cube roots, use the u substitution. No, it doesn't. That's not one of those. Is it piecewise? No, it's not. Is it absolute value? No. I skipped the most important one. It factors. Yeah. And I don't know, you can take a lot of math and never see something more beautiful than this. Now I can sub in 0 and get negative 5 as the slope of the tangent. Okay, the blaring question is, this is better? Stay with me for a while. I wouldn't lead you astray. Stay with me for a few days, maybe 9 days, 10 days, and you'll go, oh, this isn't a little bit better. This is way better. We've got another fight to put in yet. We had to fight with 2.1, 2.01, 2.001. Now we got to fight with h a little bit, but I promise we're going to step out of the woods soon and go, ha, 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 and it's going to be worth it, okay? It would be fair to say the advanced functions people would have been done this question a few minutes ago. Yeah, so right now, it's like, is this better? Yes, it's way more powerful. I've given you something more powerful. Any questions on the last algebra, though? That was part A, though, wasn't it? Part B was find the equation. Insert page, blank page after current. Did it work? Yes, it did. Now, the question didn't actually say part B, did it? I made that up to go part B. When it says find the equation of the tangent, step 1, get the slope of the tangent. M tangent equals, was it negative 5? If I'm going to find the equation of a line, I need the tangent, but I also need a point. But the good news is they always provide that. There it is right there. We're at 4, negative 9. Yeah? Point 4, negative 9. And you y equals mx plus b people, yes, go ahead. You can be y equals mx plus b. I have no issue with that. If I make fun of it, it's just me having fun. It is not, mathematically, it's fine to use it. But many of you, I think, on the test switched over to this because it's a little faster and more convenient to build an equation. That is, you can go y equals, put the negative 5 right there, and put the point right there like that. The y equals mx plus b people go, well, what if you do? It's fine, but what if you do need y equals mx plus b people? And the y equals mx minus p plus q people go, yeah, you want y equals mx plus b? Okay, I'll get you y equals mx plus b. Just a second. y equals negative 5x plus 20 minus 9. You just have to multiply out the brackets. But again, y equals mx plus b, I have no issue with that. I'm not arguing with that. You go ahead and use that if that's what you're used to and that's what you like. This isn't such a big time saver, you know. Saves a few seconds maybe at most. Okay with this? No more horrifying feeling on a test than it says find the equation of the tangent. You find the slope of the tangent, you're like, oh good. I did it. And then you get it back and you got 5 out of 6. You're like, what 5 out of 6? It's beautiful. And then you read the question, you're like, okay. So one good move is as you're walking up to hand-in tests from here on in, you're reading the question and seeing if you answered the question. Yes? Because it's easy to get caught up in the algebra and forget to do that. Other questions there? Can we do another one? Yeah, sure. Let's do it. Let's do something with cubes, though. As long as we're practicing our algebra, why don't we practice our cube algebra? A little faster this time. Find the slope of the tangent. As soon as it says that, you don't even read the rest of the question. You go, m tangent equals limit as h approaches 0, f at a plus h minus f at a over h. If you don't have it memorized yet, you won't be able to help it. You'll write it down so many times that you'll have it memorized. Or maybe you write down this version of it. Limit as h approaches 0, f at 2 plus h minus f at 2, because I told a giant lie and said I'll always give you that a value. I'll always give you the x value that you need here. We'll get to what we do when I don't give you the x value. Don't worry. If I don't give you the x value, I have to give you the slope. And then you'll work it backwards. But just don't worry about that for now. All right. So then you sub this in and start to cry. So get your Kleenex out. Oh, I forgot the cube. And I forgot a squared. That's the kind of mistake you're going to make all the time on these. Now here's what I do. And you're going to do them so many times, you're going to get so good at these, it's ridiculous. Once I have that line, then I go, okay, there's two major pieces of algebra I got to deal with. And I'll just move my screen recorder down there for a second. 2 plus h squared. I don't do that algebra within the numerator, writing line after line of simplification, just because I have to take 2 plus h and square it. And you'll get so good at squaring binomials that you might not even show this work. You'll be able to do this in your head because you'll do so many of them. 2 plus h times 2 plus h, I get 4 plus 2h plus 2h plus h squared plus 4h plus 4. You're just going to have to believe me that that will become easy. Due to pure repetition of squaring binomials, you'll get really fast at them. Okay? But I usually do it up here, not in here, because it makes a big mess and takes a whole bunch of lines of algebra. The other thing I need in a cube question is 2 plus h cubed, which is 2 plus h squared times another 2 plus h. But the way I've created this, I've made my life a little easier because I'm doing it right under 2 plus h squared. So I already know what that one is. 2 plus h squared. Now I just got to multiply it by another 2 plus h. I mean, the way I'm saying that, you're like, you're making that sound really easy, Mr. Todd. Oh, now all I got to do is multiply by 2 plus h. Because I got a giant distribution I got to do here. Am I going to have enough room? Maybe just enough room here. Enough room for 2 lines here. 2h squared plus h cubed plus 8h plus 4h squared plus 8 plus 4h. Geez, even I had to stop for a second and focus on what I was doing to not make any mistakes. And you, boy, you are going to, function will not be the F word you use while you're doing this. You'll forget a 2, you'll forget a negative, a 4. You know, it's going to drive you around the bend. But you'll get better at it. You will improve. Did I check it all? Is somebody out there checking? I encourage you to do your homework together, too. Yeah? Have homework parties where you're just doing algebra together. That's how you find out if you make a mistake. Don't get together with your friends. Friends distracting. You want some people that you sort of like, but not really. Yeah? That way you focus on your work and don't get distracted talking about other things. Like the Kansas City Chiefs and Taylor Swift. What the heck is going on? Jeez. Society's coming to a halt over a rock star going to a football game. Woo! Yeah, don't even ask. It's unbelievable what's going on. We're talking about music and a piece of leather, and we can't even get through the day. Yeah? We can't even deal. She was at the game. Yeah, I know. It's just football. Chill out. All right. You will love this, and you will get better at it. Now, incidentally, where's the data management people? Yeah? 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3. Yeah? That's why that stuff was in data management. You don't need it here. But I'm not going to make you do any more than a cubic on a test. But if it was degree 4 or degree 5 or degree 6, the data management people would be like, yeah, that's no problem. And they'd expand it out very quickly. Would it be very quickly? Well, Robbie says, when I was good at it, maybe. Yeah, all right, yeah. All right. But theoretically, we could do it. Okay, so now we got this mess. Where was that 2 plus h cubed? H cubed plus 6h squared plus 12h plus 8. And then the 2 plus h squared was h squared plus 4h plus 4 minus 8 minus 4h plus 5. And then minus whatever this big mess in the bracket is. Let's not carry that around any longer. I got 20, 12, I got 17. Anybody got their calculator? I'm trying to stay young and do them in my head. No, it's not. Yes, it is. It is minus 17. It's 17 in the brackets, and I'm subtracting 17. Somebody on the case here? 20 minus 8 is 12 plus 5. I like it. All over h. I'm going to do that whole dramatic speech again after I multiply out these brackets, okay? I'm going to multiply out one more set of brackets, and then I'll do the dramatic speech about what the heck is going on here. 2h cubed plus 12h squared plus 24h plus 16 plus h squared plus 4h minus 4 minus 8 minus 4h plus 5 minus 17. Yeah. I hope that made it on the video. That would be hilarious. Did someone just say?
It's plus 4.
Where?
Where it's after the point.
Algebra strikes.
Plus 4. Great catch. And this is why you have to do it with friends. I'm glad that happened. Did you get minus 17? Oh, I got plus. Did you get plus 7? 7? That's, you don't talk for 3 straight hours. All you do is just back and forth. Ilya's question. Not as many as you think, right? You're going to run out of time. You know, maybe a cubic, a squared, and like one that's like a square root or something. All right, hold on. Here's the dramatic question. You're like, this can't possibly work, can it? Eventually, I got to sub in h equals 0, and there's going to be 0 in the denominator. What's the only way it can work? It's got to come out to 0 in the numerator, too. What I mean by that is let me collect these up, and I'll do the big surprise reveal here in another way. I'll just start collecting like terms. 2h cubed. Got that. H squareds. 12. H squareds. Another h squared. And that's all the h squareds. H's. 24H, 24H, 28H, back down to 24H. Oop. Constants, 16 plus 4 is 20, minus 8 is 12, plus 5 is 17, minus 17. That's beautiful mathematics. And a self-check in this a little bit. If that doesn't happen, like if Chris hadn't caught this and it was minus 4, at this moment I'd be like, wait a minute. It's not right. And in fact, you'd know. You'd be like, minus 8. I must have missed a 4 here, half of that. You know what I mean? You'll get good at troubleshooting this all. So now I can't resist putting over H and putting a smiley face there. Now it's better than advanced functions finally. And some people don't even common factor out the H, but I suggest you do, because there's a bigger idea looming here, that this function has a hole. And even though I can't sub in H equals 0, because that would mean the gap between the 2 points is 0, and that doesn't make any sense. That's what the algebra is trying to tell you. It doesn't make any sense to sub in 0. I can find out where it's going, though. Where is this slope heading towards? And it's heading towards limit as h approaches 0 of 2h squared plus 13h plus 24 equals 24. Two more to go? Can I make it? I don't know. I pause for questions. What questions do you have? If you're right with me, like, okay, every question is going to be exactly the same. I start with this, f at a plus h minus f at a over h. I do up my seatbelt. I sub in and go. Ilias. Two reasons. First reason is if I sub in 0, I'll get something over 0. Or I'll get 0 over 0. Rewind, what's the big reason? That would be saying I want to take the slope between 2 points that have no gap between them. Yeah? We can head towards 0. We can head towards 0 and say, what happens as I get so close to 0 and I get equals 24? Not approximately 24. Not like 24.01 around there. With the limits now, it's like, it's 24. Yeah? We must move on. Determine the slope of the tangent f at x equals root x at x equals 9. I think these are easier than the polynomials. The polynomials get squares and cubes and brackets and negatives and all this stuff. These are nice. Just have to be careful here. M tangent. Again, your new best friend. Limit h approaches 0, f at a plus h minus f at a over h. Or in this case, limit as h approaches 0, f at 9 plus h minus f at 9 over h. Those first two lines are the same no matter what function. You don't even have to look at the function to know those are the first two lines. Then, limit h approaches 0. Sub it in, root 9 plus h minus root 9 over h. Don't panic yet. Because they were at least a little bit kind in the x value, the a value that was chosen here because it was a 9, and I can take the square root of 9, and that's 3. And if I sub into that, at that moment, I get root 9, which is 3, minus 3 is 3. I get 0 over 0. Now we need someone who's done their homework. What happens when you got a square root in there? The conjugate. The conjugate is how I can evaluate a 0 over 0 limit. Oh, that's why we had all that homework. Geez, maybe I should have done that. It's worse next year, folks, at university. Hopefully you're still following the lesson even if you didn't do the homework. Next year it starts to become where it's like, I can't follow the next lesson if I didn't do the last homework, and then things start snowballing out of control. Anyways, conjugate root 9 plus h. Sorry, my writing. This active board. You see what it does over there? It can't even do straight lines anymore. Now, how good are you at these? For just a moment, I'm going to be a giant jerk and act like you've done your homework. And if you haven't, you're like, oh, maybe I better do a few of those from homework. Because multiplying out this numerator is much easier than it looks if you know what's going on. Root 9 plus h times root 9 plus h is 9 plus h. That's why the conjugate is so amazing. It makes roots disappear with its conjugate. I'm going to skip over the other two steps. What am I going to get? 3 times root 9 plus h, negative 3 times root 9 plus h. That's the beauty of the conjugate. Those two things go. I don't have to FOIL these. I can just FLU them. Because the OI is perfectly designed to cancel out. And then I get minus 9 here. And just stare at that numerator for a second and savor what just happened there. Something beautiful just happened. Little piece of advice, do not multiply out the other part. Conjugates are meant to multiply with their conjugates, not with other random stuff. Conjugates stick together. And again, you have that dramatic moment where you're like, yeah, but it's still going to sub in and give 0 over 0. I'm like, keep going. 9 minus 9. So good. H over 8. Oops. Got too excited. Forgot to write limit as h approaches 0. H bracket root 9 plus h plus 3. The h's cancel because it's a whole. I can't sub in 0, but I can find out where it's headed towards. And I get, after I sub in 0, I get 1 over root 9 plus 3, 1 over 3 plus 3 equals 1/6. For the first time, maybe we're better than advanced functions. The advanced function people would have done it faster, and they go, I don't know, it's about 0.166 something, I don't know, somewhere in there. And we're like, no, it is exactly 1 over 6. So we could get a job at Apple, not at Samsung. I think these ones are easier. I might have showed too many steps here, actually. The conjugate ones are going to be less steps. By the time you're done, you're going to be like, put the square root on there. Don't put a cubic on there. Come on. Like, Mr. Todd, seriously. The cubic ones are crazy. It's okay, though. I'll put both, so it'll be all right. It's a good chapter like that. The night before, you're like, if you're studying for this, you're like, you think you'll put a cubic on there? You're like, he's going to put a cubic on there. You think he'll put a square in there? He's going to put a square root on there. Come on. Questions there? Cam.
Why is it that you have to multiply, like the conjugate has to be root plus 3 instead of it being multiplied by root minus 3?
Oh, if I used minus 3 there, I wouldn't get the OI cancellation. See, I only did the FLU. Root 9 plus h times root 9 plus h is 9 plus h. Root 9 plus h times 3 is 3 root 9 plus h, and you panic. You're like, it's not going to work. But then the very next term is negative 3 root 9 plus h. That's why it has to be positive and negative for that OI thing to work and cancel out and end up with no square roots in the numerator. I've moved the square root to the denominator, allowing me some unbelievably shocking algebraic cancellation. Okay? More time there? In the interest of finishing the video, I'm going to do this one fairly quickly. Determine the equation of the line that is perpendicular to the tangent. Ignore all that. Part A is always m tangent. Get the slope of the tangent first, then I'll answer the question later. Limit as h approaches 0, f at 2 plus h minus f at 2 over h. This one's with a fraction instead. So I get 1 over 2 plus h minus 1 over 2 all over h. Stick around for just another couple of seconds for dealing with fractions here. just like the conjugate, there's a magical thing to multiply by that tidies this up in a hurry. You really want to know this move. The magic thing is multiply top and bottom by the common denominator. And I'll write the next line, and you should freak out a little bit. But stare at it because it's really awesome algebra. So I'll draw a dotted line there, so when you're asking me questions, you can tell me whether your question's above or below the dotted line. Because that is a magical line of algebra, which you're going to love once you understand what's happening, but then I'll finish off the rest of it. But tell me. What the heck happened from the bottom of the page to the top of the page? That's what you should be asking. Look carefully and slowly. Stop writing for a minute and look. If I multiply 2, bracket 2 plus h, times 1 over 2 plus h, the 2 plus h's go. And I'm left with the 2, which makes me happy. Just like getting rid of the square root in the numerator, I'm trying to get rid of the fraction in the numerator. If I multiply 2 and 2 plus h times 1 over 2, this time the 2's cancel, and I'm left with 2 plus h. Don't give it too much credit here. Just look at it a couple times till you go, oh, that's cool. You might have to show an extra step there as you're getting used to it, but that is not mind-blowing. That is not the mind-blowing part of the lesson. You just got to look at that long enough to see, I see what you're up to there. What happened after the dotted line was not exciting. It was easier algebra than the cubic was. And then part B is m perpendicular would be 4, and then my equation is 4 bracket x minus 2 plus 1 over 2. But that's really fast, so I know there should be questions there about what I did there. I absolutely believe there should be questions there. But I'll get it all on the page so that you can look and see what questions you have. 4x minus 15x, negative 8. Yes, it's right, it's right. Yes, it's good. Tell me. Todd, I don't think I can do all this calculus and have a job and a boyfriend or girlfriend at the same time. You're right. It's time to quit that job. Break up with that person. You can get back together with them in June, maybe. They'll still be available. You're a good catch. Don't worry. It'll work out. I'm sort of kidding. If the job is distracting you from your work, this is the biggest year of your life, get rid of the job. If the spouse is distracting you from calculus, you can do better. You'll go off to university. You're going to meet someone better anyways, so you may as well. Yeah. If that hits too close to home, actually.
Like I did it, but I'm not going to go up to a couple of like, yo, I have this great idea,